Okay, so this is lesson 4, covering how to calculate molar mass. The things that you should be able to do once we are done this is understand that molar mass is related to the number of atoms in a compound. Determine the number of moles and mass using molar mass. Report calculation to the appropriate number of significant digits. Okay, let's go to this table here. Before we get into actually converting, I want us to be able to successfully calculate molar mass. In order to successfully calculate molar mass, you need to be able to write a chemical formula. Now, magnesium hydroxide looks like this. The most common mistake that I see with calculating molar mass is having an incorrect chemical formula. So make sure that your chemical formula is correct. Now, this is kind of a gateway here where we are counting the number of atoms. It's going to help us calculate molar mass. So for magnesium, I have 1 atom of magnesium. Oxygen, I have 2 because there is a 2 outside of the bracket, so I multiply that. And hydrogen, I also have 2. Now, let's organize this and calculate our molar mass. Magnesium has a molar mass or an atomic mass of 24.31. So you're going to multiply that. 1 atom of magnesium multiplied by its atomic mass, which is 24.31. Oxygen, I have 2 atoms. I am going to multiply that by 16. And hydrogen, I have 2 atoms. Multiply that by an atomic mass of 1.01. Now, we are going to total this up. So this gives me 24.31 plus 32 plus 2.02. Once I calculate that all out, I should get a molar mass of 58.33. Okay, so the answer for this is 58.33 grams per mole. Okay, do not forget the units because in chemistry we are going to be dealing with a lot of numbers. So I want you to get into the habit of putting units on as you go. Okay, next example that we have is calcium carbonate. So the name of this compound here, CaCO3, is calcium carbonate. Again, when we are counting our atoms, every time we see a capital letter, that signifies the start of a new atom. So calcium, I have 1, carbon, 1, oxygen, 3. Let's lay this out in our table here. You're going 1 times 5 the atomic mass of calcium, which is 40.08. Carbon, which we have 1 atom of, multiplied by 12.01. And then we have 3 oxygens multiplied by 16. Okay, this gives me a total of, calculate this out, 100.09 grams per mole. Okay. So strontium nitrate is going to have a chemical formula of SrNO3(2). Okay, make sure that you've written this chemical formula correctly. A lot of people forget that there are 2 nitrates. Okay, and you should get a molar mass of 211.64 grams per mole. Okay, so now let's use molar mass to convert into grams, grams into moles, moles into grams. So a couple side notes here. We can go from grams to moles and moles to grams, okay? But we are going to use a converter, and that converter is called molar mass. Okay? The reason why it's a converter is because it contains both units. I want us to get comfortable with the idea of if you have mass, then you are able to find moles. If you have moles, you are able to find mass. Okay? Now, the question is asking us to determine the molar mass of the following compounds. First thing that you want to do is write a chemical formula. So the chemical formula of chromium oxide is Cr2O3, okay? Now let's find our molar mass for this, which you should get 52.00 grams per mole, okay? Now this here is it's a ratio. And a ratio we can represent in two ways. I can represent this molar mass as 52.00 grams per mole. Or I can flip this ratio and represent it as moles for 520 grams. This is representing the same ratio. Does that make sense? Yeah? Okay. Okay, example 1, find the mass of the chemical amount using the chemical amounts of each compound. Chemical amount is another name for moles. Okay, so if you see the word chemical amount, the units that we are using is moles. So first thing you're going to do is write a chemical formula, which we already have here. Using the chemical formula, you are then going to calculate the molar mass. The molar mass for this compound is going to be 261.35 grams over mole. Okay? And we can also represent it like this, 261.35 grams. Okay? Now, we have 1.2 moles of this compound. We want to find out what the mass is associated with that. So I take this number from the problem and begin my unit analysis with it. So I have 1.2 moles of barium nitrate. I am now going to use a ratio that cancels out the moles. So moles is currently in the numerator. In order to cancel it out, I have to have a mole in the denominator. So if I were to pick a ratio, A or B, which one makes sense? A, right. So A, we're going to go 261.35 grams per mole. Mole cancels out, and I am left with grams of barium nitrate. In your calculator, you're going to plug in 1.2 times by 261.35. That is going to give me an answer of, here's you an answer of 313.62 grams. Okay. Now, we need to establish how many significant digits, and we're going to look at the information that was provided. This here tells us that we have 2 significant digits. So my final answer needs to be in 2 significant digits as well. Can I represent 313 with 2 significant digits? No, so we need to use scientific notation. So that's going to give us an answer of 3.1, and now we're going to move our decimal. 1, 2, it moved 2 up, so that's going to be times 10 to the power of 2 grams of barium nitrate. Okay, Now we have 1.5 moles of zirconium oxide, and again, we are looking for mass. First thing what we need to do is what? Write a chemical formula. Good. The chemical formula for zirconium oxide is ZrO2. Then what do? Find molar mass. Molar mass of this compound is 123.22 grams per mole. What number do I start with? What's in the question or my molar mass? Which one? The moles or the molar mass? The moles. So we start off with this number that's provided. 1.50 moles of zirconium oxide. We then need to select the ratio. The ratio, do we want grams in our numerator or denominator? Numerator. Okay, so I go 123.22 grams per mole. What's canceling out? Moles. What am I left with? Grams of zirconium oxide. Good. Again, in your calculator, you are going to multiply. So 1.5 times by 123.22, and that will give you your answer. In your calculator, you get 184.83. How many significant digits am I allowed to have? 3, and we get that from here. Remember that trailing zeros count as part of your significant digits. So my final answer will be 185. What's the unit? Grams. Good. Okay, so determine the number of moles, or the chemical amount, from a given mass. First thing we do is we write a chemical formula. We already have one provided, so we do not need to do that. Then we calculate our molar mass. Molar mass for calcium fluoride is 78.08 grams per mole. Okay? Again, this can be represented as a ratio. So we have 78.08 grams per mole, or we have moles over 78.08 grams. Okay, those are the two possible ratios. Let's say it's representing the same molar mass. I'm going to start with the number that is provided in the question, 2.35 grams of calcium fluoride. And then I need to select a ratio. Does it make sense to use A or B? B. Okay, so we put B in, moles on top, 78.08 grams. Notice how grams does not separate from the number. See how it's attached to the number here? It remains attached, whether it is in the numerator or the denominator. Okay, what's canceling out? Grams. And we are now left with moles of calcium fluoride. Now, in your calculator, what you're going to do is you're going to go 2.35 divide. If it is in the denominator, you divide. D for denominator, D for divide. So I divide by 78.08, which gives me an answer of 0.030097. How many significant digits am I allowed to have? 3. Question for you guys. Do these zeros count as part of sig digs? No, these are called leading zeros, and they do not count when you are reporting your final answer with sig digs. So my final answer is 0.0301 moles. We have 30.28 grams of iron 2 oxide. determine the chemical amount. Now, what do we do first? Chemical formula. It's going to be FeO. The molar mass is going to be 71.85 grams per mole. What number do I start with? 30.28 or my molar mass? 30.28. So I start with that, 30.28 grams of iron 2 oxide. We are then going to use our molar mass. Am I going to divide by 71.85 grams, or am I going to multiply by 71.85? Divide. So 71.85 grams, moles in the numerator, grams cancel out. Again, in your calculator, you are going 30.28 divided, because our number is in the denominator, divided by 71.85. Okay, so it's dividing because it's in the denominator. When you plug that in, you get your final answer to be 0.4214 moles of iron oxide. Okay, we need 4 significant digits. This leading 0 does not count. So we have 1, 2, 3, 4.